All right, hi everyone. Thanks for coming down this evening and braving the unfortunate wet weather we've been having just this evening. Before we get going, just going to do the normal announcements. So first of all, fire safety. In the event of a fire, please exit the same route you came in, straight down those stairs. If that route is blocked, a member of staff will escort you to an alternative exit. Can brown watchers just please raise their hand to make themselves known? That's awesome, thank you. And please don't let any belongings block the exits if you have any with you. If you have not signed in, please do so now. And also be aware that the building is now locked. So if you do leave, a member of staff will need to let you back in again. And if you do leave the building, please be aware the reception doors will set off an alarm if they're open for more than 2 minutes. So please just don't stand at the doorway and have a conversation there. That'd be awesome. And please don't go past the Brown Watch reception desk that way because that is Brown Watch offices. And also I think there's another event happening this evening. So yeah, please stay in this area. If you've not found the toilets already, they're down this corridor. And obviously, I think most of you guys have found the pizza by now. It's on the back table over there. This evening is being sponsored by Brown Watch. They're providing all of the refreshments, all the food and drink, and also the venue, of course. So thanks to them. And this evening, the talk will be by Almas Baimagemetov. He is a lecturer at the University of Brighton. And he will be talking to us this evening about games development in Java. So Almas, over to you.
Hi everyone, thanks for coming to this talk. Today we'll be looking at JavaFX game development with the aim of this talk to promote both of these technologies as something that you can use for game development. I would have been introduced, so I'm going to skip that. The only thing I'm going to mention is that I'm the author and maintainer of the FXGL game engine, which was part of this talk. Right, so we'll look at the current state of Java game development. We'll look at some frameworks that currently can be used to develop games. We will identify certain things that can be improved with these frameworks, and this is where FXGL comes in, which is going to attempt to fix or improve these frameworks in that particular area. And finally, we'll look at some cross-platform support provided by FXGL. And at the very end, surprisingly, I'm going to summarize. That's the only joke of this talk, so please feel free to laugh if you find anything funny. I'm not going to stop you. A couple of notes before we start. No assumptions of prior experience in game development or JavaFX. So if you're not familiar with these technologies, then that's fine. We're going to look at everything from scratch. For simplicity, I'm not going to mention any of the stuff that comes after Java 9. I'm assuming Java 8 is the common ground and that most of you have experienced Java 8 by now. I will note, however, that FXGL supports all major versions of Java from 8 to 12. OK, so we're going to start us off with a simple question. Is Java viable for game development? And I think it has been spoiled by the title. So the answer is obviously yes. Here's a screenshot of a moderately popular game called Minecraft, which was initially written in Java. So we know that Java game development is possible. Now, to manage the scope of this talk, I'm going to start with the AAA game development not being in the scope. That gives us the upper bound, so we're not going to talk about AAA game development. And the other end of the scale is the lower bound, so things like Pong, Breakout, something that you'd play in the 80s, 90s. That's a bit too simplistic for this talk, so we're not going to cover that either. So we're looking at something that is in the middle. This is something that resembles a game. Graphically, not too complex, not too simple. And it's just aesthetically somewhat pleasing, so something that looks like a game is what we're aiming at. By the way, this is a screenshot from unfinished game, which was supposed to be a 3D maze game, where the walls would, at a certain interval, rearrange themselves. So dynamic maze layout. Right, so we've established that we can make games in Java. And a follow-up question could be, where do I start? These are a couple of frameworks which are quite popular, actually. libgdx and JMonkey 3D, and lightweight Java game library is essentially a library to build game engines rather than games, but I've included it anyway. So libgdx, it's a all-around great cross-platform framework. However, it can lack in high-level concepts. And I'm going to explain what those high-level concepts are on the next slide. And so this is what we're trying to improve with current existing game frameworks. JMonkey 3D, it's, again, a good 3D framework for making games, but can be awkward for 2D stuff. And I will explain that LWJGL is too low level. So what do we mean by low level and high level, which is pretty much the same in software development as in game development. Low level refers to implementation details, whereas high level refers to abstractions. A low level concept could be something like handling input on press of a W key. So we have a loop which does while true. If input W is pressed, then we jump. This is very old school infinite loop which constantly checks for W key. A higher level alternative is to say when the W key is pressed, then we jump. So we're essentially flipping the call. Instead of calling the library, we're letting the library call your functions. And this is the whole idea of callbacks, listeners, event handlers, which you all have been using for UI programming. Another example, which is drawing. So you might have a low-level drawing instead of, you want, suppose, a rectangle on the screen, and you can issue commands to the GPU saying draw a line here, 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 there, and you have a rectangle. This is a bit too low level. At high level, you have a scene graph representation. You say, I have a rectangle in my scene graph, draw it. I don't particularly care how, but I want it to be positioned over here somewhere. So these are the examples of high-level, low-level concepts. And the argument is that current frameworks can lack in those concepts, especially in high-level ones, because high-level ones are more of an abstraction and hopefully is more beneficial for beginners. This is where FXGL comes in. It does not compete with any of the existing frameworks. It fills a gap that is arguably there. And these are just some examples of demos, games that can be built with FXGL. So now that you're convinced that we need FXGL and FXGL is good, I'm going to give you a sales pitch. No installation, no setup required. You basically plug it in as a library, and you're good to go. You can use UberJar if you're not familiar with build tools. If you are, then Maven and Gradle are fully supported. Out-of-the-box support for Java 8 till 12, so all the versions 9, 10, 11. I will also note that modular system is fully supported. So if you're using the Java 9 and higher module system, then you can get a modular architecture from FXGL. In terms of platforms, we have the three major desktop ones: Windows, Mac, Linux, and mobile, Android, iOS, plus the web, but more on that later towards the end of the talk. Simple and clean API. I try to make it as clean as possible, at least externally from the client-side perspective, and definitely higher level than other engines. That's the USP of this framework. And in terms of API, it's superset of JavaFX, so there is no need to learn new API. If you already know JavaFX, you just continue using the UI API, so you already know about 50% of FXGL. Real game development tools, techniques are integrated into FXGL, so things like that you might see in AAA titles, QuickTime events, cutscenes, achievements, notifications, custom scripting. All of these things and a bunch of other features are provided just out the box with FXGL. Finally, games are easily packaged into a single executable jar. So you type something like Maven package, and it gets all of your assets, images, sound files, text, level data, and gets all of that gets packaged into a jar file that you can simply run. Okay. In terms of the community, so these are academic or otherwise institutions that have told me that they're using FXGL. to teach game development or software development. So it just shows that there must be something in FXGL that can be used for teaching, and especially for beginners. Some download stats. I'm assuming December is where everyone started doing their homeworks, because it's really useful for things like homeworks, because they're not too complex projects. Some GitHub stats. We're just reaching about 900 this month of GitHub stars, which is not much on a larger GitHub project scale, but it's something. And that means basically people know that framework exists, which is good. Right, so some code. There's not going to be much code. Minimal example how you might use FXGL in your application. And there are two things I like about this example. First, I think it's simple. If you can also get rid of the settings calls, the 3 lines, because the defaults are provided. And the other thing is it fits on one slide. This is now one of my criteria for code listings, because it's a lot easier to talk about code if it's on one slide. In terms of architecture, it's rather big. It has lots of things like AI, scripting, scene graph, graphics, maths, cross-platform support, and it spans across 2 slides. So we're not going to look at all of that. We're going to just pick 2 things, which are possibly the most interesting things: entity component architecture and JavaFX toolkit. So essentially what entity component is and what JavaFX is. Before we continue, entity component architecture comes in different flavors. So the most traditional one is called ECS, Entity Component and System. And in FXGL, we're using the entity component, the shortened version. There's no system, since we're not using a data-driven approach. So imagine you have this problem. I'm going to justify why we're using entity component. Imagine we have this problem in object-oriented style. You have 2 superclasses, NPC and Decor. NPC can attack and has HP. Decor does not have HP and cannot attack. And Tree has HP and cannot attack. So how do you kind of create an architecture for this? What is Tree? Is it a subclass of NPC or is it a subclass of Decor? So we can try to have an interface. We can isolate common functionality into interfaces, or at least abstractions of. Whenever you have multiple inheritance in Java, you tend to think, well, we can create an interface with that. But however, we end up with duplicate implementation and NPC and Tree, because both HP implemented is in both NPC and Tree. And as we all know, code duplication is bad, because you change it once, you have to change it in some different place. Imagine you now have a third game object, which also implements HP, so you'd have to change all of that. By the time you realize, you've just recommitted the entire project code base, and you don't want to do that. So can we move methods to interfaces? Yes, we can. Since Java 8, we have default methods. But do you really want to do that? The whole point of interfaces is to be abstractions, and the whole point of concrete classes is to be implementation details. That's the whole contract. We don't want to muddle these things in one class. Plus, we don't have state in interfaces. If we did, it would just be an ordinary class. And so this is not a viable solution. This is not a solution at all, I think. Now, keep that problem in mind. We're going to come back to it. This is an example of a game written in FXGL, and it shows the entities, all of the entities that are potentially possible. So everything is an entity in the same way as everything is an object in the object-oriented paradigm, everything is a function in the functional paradigm. In this paradigm, or style, everything is an entity. The explosions, the player, the particle effects, the UI objects, the circle in the middle, the timer data, even the background, everything is a unique entity. So think Java object that has no fields. And component is the thing that holds data and behavior. So an entity is basically a collection of components, nothing else. And here's an example of a component which holds data, x and y, and it holds behavior, so we can move in 2D space. Now let's come back to the problem that we had. If we define this problem in terms of entity component architecture, then we have NPC has HP component and attack component. Decor doesn't have any components, and tree has HP component. So all the code related to HP is now isolated in HP component. And we just solved the problem by simply defining it in different terms. NPC, decor, and tree are no longer in any of the hierarchical problem because they're all at the same level. Both three of those things are entities. They're of type entity. And there's no code duplication since we have HP component separate. So problem solved by design, basically. And in my opinion, this is one of the best solutions possible if you're solving a problem by design, because then you can expand and scale, and the whole design will still support what you're trying to solve. We have an entity example, which is just you create like any other object. You can then add a position component. So from then on, that entity knows about its position. Before it didn't. It didn't know anything about itself, because an entity is simply a collection of components. If there are no components, then there is no information. And you can add WASD input component to an entity, in which case you can then control the entity by using the WASD keys. And with great power, as we all know, comes single responsibility. All of the components are designed to follow the single responsibility principle. So, and with that comes loose coupling and all the good stuff that is implied by that. So you don't need to worry about compatibility. You take one component, you take some other component, you mix and match them, you throw them all at once at a single entity, everything will still work, everything will still be operational. Because generally speaking, there are no compatibility problems between components, because they all operate on their own limited set of data. And I'm just going to mention very briefly about bindings provided by JavaFX. So imagine you have two different components, view and position. These two components are separate, so they operate on their own data. However, they need to share some data, because view needs to know about position in order to be able to draw the entity correctly. So how do we do that? We take view component, x and y values, and we bind those values to position components, x and y values. So we bind data of one component to some data of a different component. And conceptually, imagine you have two variables. You bind one variable to the other, so then whenever this variable updates to a new value, the other variable automatically updates, which is superb, because you're not exposing any of the data, you're not listening for any changes, you're not doing anything manually. Everything is automated. And that's something that's provided by JavaFX and extended in FXGL. So just to summarize, on the entity component architecture, we have everything is an entity. We have components that hold data and behavior. And if you're thinking in terms of OO, then entities are like objects, and components are like fields and methods. But the great thing is that you can remove and add those fields and methods at runtime. Okay, so that completes the logical side of things. So we represent game objects as entities, but how do we do the drawing of stuff? And this is where JavaFX comes in, which is the successor of Swing as the next-gen graphical user interface for Java. It's currently maintained by the OpenJFX initiative, which means it's open source, it's community-driven. We get updates reasonably frequently, and it's no longer tied to the JDK. So we can use JavaFX as an external dependency using Maven, Gradle, or UberJar. And there's also the scene builder tool, that you can use to drag and drop design your user interface very quickly. So it's really good for prototyping. And we'll talk about cross-platform later. So for those not familiar with JavaFX, this is how it represents things to draw on the screen. This is called scene graph architecture. You have a stage object at the very top, which is a wrapper around the native window that is provided by the operating system, which holds a scene object. And that scene object contains the entire scene graph, which starts with a root node. It's the parent node of everything else, which is typically a layout node, a layout container. So it could be a vertical box to position things vertically. It could be a horizontal box to position things horizontally. It could be a grid pane that you'd place things in a grid-based layout, and some other layout containers. And then you can have parents, children, so it's typical graph. Leaf nodes are typically some kind of controls, like text object that is shown on the screen, or a button, for example. Here's a more concrete example. On the left, you see the window representation, which is the stage, in which there is a scene, and in that scene, there is a stack pane, which is another layout container. And finally, we have the leaf node, which is a text object that says hello world. I don't know if you can see hello world, but it's there in the window. And on the right, there is a scene graph representation of what it looks like. And this supports high-level drawing. So we have retained drawing mode. We say what something is rather than how to draw something. And for example, we have an add component we can add a view component to an entity. New rectangle, this is a software generated shape. We say the dimensions of that rectangle. We say what color it is. And that's pretty much it. We don't say GPU, draw a line that, or draw a line that. Everything else is done by JavaFX. Alternatively, we can use images, textures, so we can read from a file system, player PNG file, and we can use that as a view to our entity. There's also hardware acceleration in JavaFX that is provided by OpenGL and D3D, Direct3D. As you can see on the left, yeah, OpenGL and D3D just under Prism. And because of that, we have really good 3D capabilities because it's hardware accelerated. This is an example from a 3D animation. So the scooter is actually animated, which I will show you afterwards. And the animation is basically there are different scooter parts, and they all get together to build a scooter real time. There's augmented reality, if you're into that kind of thing. This is not my image, so I can't say much about it. Apart from that, it's really cool. So you can do augmented reality stuff with your mobile phone. Okay, so let's look at some of the cross-platform support provided by JavaFX and FXGL. One code base to rule them all. I always wanted to sneak in a reference from The Lord of the Rings. So on desktop, that is reasonably simple. Most of the stuff is already there, plus Java, so cross-platform is implied. On Android and iOS, things could get tricky. And the web is provided by a third-party project called JPro, which I don't know much about, apart from that it creates HTML page, and you can use that to deploy your JavaFX stuff on the web. So we're going to look at desktop platforms and the mobile. Essentially, you have this top-level JavaFX API, which is super high-level. It's a bunch of abstract classes and interfaces that you can use to communicate with JavaFX. And then you have, for 3 desktop platforms, 3 different providers or implementations of that drawing. On Windows, it's Direct3D. On macOS and Linux, we've got OpenGL. This is a very simplistic look of how it works. You have this abstract function, which could be drawPixel, and this drawPixel function gets implemented by Direct3D, OpenGL, etc. So if it works for desktop, can we extend that to mobile? And the answer is yes. And that concept can be extended and has been extended by the JavaFX ports project developed by Gluon, who are currently also leading the JavaFX, OpenJFX initiative. And essentially, you have the same schematic diagram. You have the high-level interfaces, and you have concrete implementations. On Android, it's reasonably straightforward because the Android runtime supports a subset of the Java runtime. You just need to add the JavaFX runtime stuff, plus you need to add your code that uses JavaFX. All that gets packaged into an APK that you can then just ship to an Android device, and it will run. iOS is different because we no longer have the luxury of the Java runtime. We now need the Java runtime packaged together with the JavaFX runtime, with your code as well, to be translated to native iOS code, something that iOS can read. And this is done with RoboVM on Java 8. Java 9 uses Gluon VM, and Java 11 and higher is now being developed as we speak on Gluon VM and Graal VM. And I think this will be out quite soon. Right, so far we've talked about common drawing or common things that are present on desktop and mobile platforms, so things like a screen. What about platform-specific stuff, hardware-specific stuff? So imagine things like camera or accelerometer, things that your mobile phone might have that your desktop probably won't. And this can also be done using the Gluon Charm Down project, which has been renamed to Attach. And again, the idea is somewhat simple. You get the high-level classes, or an interface in this case, which is called audio service. And imagine that we're trying to load an audio file, which is not related to a particular platform. So there will be different implementations. Desktop, super easy. You just implement the audio service class interface, and you use existing classes to load your code. There isn't much going on here. With Android, it's slightly different because, well, first of all, you will need to have Android-specific classes, so things like sound pool. The file system access is slightly different because you're no longer accessing the file system directly. You have this private storage thing on Android, which you can use to read your audio file. But again, it's Java, pretty much. iOS, this is where things get tricky. You no longer have Java. Well, you create two layers to access iOS stuff. You get higher level bridge between your code and the native iOS code, which is currently called Audio Service Provider, well, iOS Audio Service. And you load the native library audio. It's at the bottom, audio.m. And you then have a bunch of native functions, or functions that are that have the native access, or not access, the native modifier. And in audio.m, which is an Objective-C source code, you do the native loading stuff. This code gets called by the high-level layer in Java that then does some native loading and throws it back to the Java layer, from which you can use the result in your own code. So that's how you go about accessing platform-specific things if you were to use this Gluon Charm Down project. Okay, at this point, I can now go to demos, which are here. some bit of sound, I think. So that is done in JavaFX 3D. It takes all these things and it animates the translation of things. So they're basically off screen and they're moved to their 0, 0, relative 0, 0 position using various different interpolators like exponential. So it doesn't move at linear time, it moves exponentially. So that was the JavaFX stuff. In terms of FXGL, we can have a look at some simple games like Pong. Although I said Pong is probably a bit too simple, but you can spice it up with particle effects, which are always cool looking. And the AI is basically just tracking the ball and going up or down depending on where the ball is. That's what AI is doing. Something slightly more complex. Clone of Geometry Wars. So yeah, lots of effects, lots of things happening. And yeah, so various things can be implemented by FXGL is the point of these demos. And one last demo is, there we go, classic Space Invaders. There's apparently some story that's happening. I don't know if you can actually read this, but yeah. That's supposed to be alien talk, alien language. And I don't know how to start the game. Oh, there we go. So yeah, there's some interesting stuff happening in there. The player is supposed to be visible. I suppose the Linux support isn't as cross-platform as I hoped. Right. So yeah, there's serialization going on, profiles. You get all of that for free with FXGL. And I don't know if I can play this. I should be able to, if it's loaded. If not, oh, there we go. That's the next gen FXGL, which is the current version, FXGL 11. So you get particle effects, smoke, Skyrim style. The buttons or the things that hover over buttons, these are stolen or borrowed from Dragon Age Inquisition. And the Skyrim smoke is Skyrim, the Elder Scrolls 5. And that particle effect just below the title, I think it's in Fallout 4 somewhere. The neon animations. So all of these are implemented from scratch using JavaFX in FXGL. Right, I think I finished pretty quickly. So I'm going to very briefly summarize, and we can then possibly move on to questions. Java non-AAA game development is very possible, as we've seen today. And FXGL is supposed to be a stepping stone before you can approach major frameworks. So for beginners with high-level concepts, that was the whole kind of takeaway message here. And finally, we have JavaFX, which is a true cross-platform GUI. You get stuff on desktops, on mobile, on web, and all with pretty much zero code change, which is great by modern standards. OK, thank you for listening to this talk. I've got some links if you want to look me up on the internet on various websites, and I'm happy to answer any questions you may have. Yep.
Yes, thank you, Olmus. As the developer of FXGL and as a lecturer at the University of Brighton, as you well know, students who study computer science or games and digital games development, we study Java in our first year, sort of like a general overview. Would you be interested in perhaps being a lecturer, perhaps, for FXGL games development in this engine for first years?
I would say this is probably too specific to run as a module, but FXGL could definitely be a demonstration tool, demonstration engine in one of the modules that focus on slightly more general problem solving, things like game engine development or just pure game development. Although Java is not typically used for AAA game development. You have C++ and you have C# and Unity, so there are other more powerful, is that the right word to use here, languages?
Okay, gotcha.
I'm going to jump in with a quick one. Seeing as we've got a couple of minutes,
Yeah.
you show us the code for the Geometry Wars one, or one of the examples.
Sure, yeah, I can definitely do that.
We will love a bit of under the hood.
Um,
And just roughly, sort of, what size are those in terms of lines of code or number of classes?
In terms of games, they're not supposed to be too complex, although Geometry Wars is it's a bit more complex than the other ones. So I have two classes here, three more. So it's 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18. There's 5 more, 23, and we have about 6 more, so 29, 30 classes, but they're not too long. So if we look at the start, for example, if you can all see that, I'm going to increase the size.
Actually, a lot less classes than I was expecting. I've seen some Hello World web apps that have more lines of code than that, pointing a finger at any particular frameworks.
Let's go with 30. So that's the general setup that you do. This is common to most games. You set up the width, height, the title, the version of your game, and the rest is not as relevant. So everything is an entity, as we've already talked about, that you represent all the game objects as entities. The input is supposed to be reasonably simple. So that defines one particular input. So you want to say on press A, I want to do something. That something is to move the player to the left. On input D, we're going to move the player to the right, and so on. These are quite nice, actually. So a game variable is something, it's a variable accessible by the entire game, regardless of what the class, what the file is. It's almost like a global scope variable, but one that can be bound to. So for example, there might be, yeah, there we go. So we are binding to, or listening for changes in the multiplier game variable, which is initiated here, initialized to 1. So whenever that variable changes, that listener will fire up and will say, well, here's the previous value, here's the current value, and do whatever you want with it. That's really nice because most games are basically event-driven software, and you want to be able to react to various events. Things like that you can use to set up to run something at a particular interval. So you can say run at interval duration of 1.5 seconds. So every 1.5 seconds, there will be a new Wanderer entity spawned, and so on. Yes.
Do you support like sprite sheets and batch rendering in your?
Yes.
engine?
We have sprite sheets. I don't know if I have an example of that here. That should be one of them. So if we go to resources and textures, so yeah, that's a simplistic two image sprite sheet, and this can be generalized.
Sure. Also, did you, like, assuming this interface is with OpenGL, did you write that yourself, or is that handled by JavaFX?
JavaFX provides everything. So JavaFX is actually a very high-level library. So most of the stuff being used in terms of drawing is just reliant on JavaFX. So if JavaFX doesn't support something, then it's very difficult to get it running.
So does JavaFX support maybe access to shaders and stuff like that?
Yes, which is very limited. You can't actually write your own shaders.
Okay, nice. Cool,
Yeah.
thanks.
Which is problematic for anything related to 3D games that really look nice. Any other questions?
Yeah, one more. What are some of the more popular games using JavaFX, FXGL, sorry? Do you know of any online that use the engine?
There is one published game called Consume. It's a platformer set in Africa, I think. And that's the only game I can think of at the moment which was published, and hence it's slightly more popular than the others. Most games end up being academic projects. So things like stuff for homework, stuff for university coursework, because it's now easier to build JavaFX games with this engine. And so most students, I'm presuming, just use that.
How have you found maintaining projects?
It can be really tricky, especially with the size of the project, because with new contributors, they all need to get familiar with almost the entire project code base, which was my assumption. And since then, I have moved from that architecture or maintaining a repository, because I've modularized FXGL. So now everything in FXGL is a module on its own. There's a module called time, which does everything related to time, managing time, running events at a particular time. There is a module called entity, which does everything related to entity component. And these are Java 9 modules. And so from now on, if a new contributor comes in, they will only need to know that module, in which case it simplifies the amount of information. Well, the amount of information that the contributor needs to know is now much smaller. One other thing that you might find quite interesting, when two things collide, this is, again, an example of how simple something can be. You just say, I have a bullet and I have a wanderer. When they collide, then do this code. So everything else is then managed behind the scenes by FXGL. It will figure out if they're both collidable. It will figure out if these both entity types have bounding boxes that can be collided. So say a box with a collision, a box with a circle. And when the collision actually occurs, then one of these will be fired, saying, well, there's a collision. This is the entity that collided with this entity. So there's an extensive use of callbacks in FXGL. And since being a framework, you're building your application inside that framework. So it's no longer a library, although it used to be. It started off as FXGL, JavaFX game library. But since then, the architecture has moved to being a framework.
So, given that games tend to spawn a lot of objects, and Java is a garbage collected language, do you get a lot of problems with stop the worlds, freezes in the middle of games, that kind of stuff? And how do you deal with that?
This could be a problem, particularly on mobile, because, well, simply because of the CPU power. Some of the things, notably things like collision events or anything that gets created several times in each frame, given that there are 60 frames per second, all of that is pulled. So you would say this object needs to be pulled because it gets created so often. And there will be a pool of pre-created objects, and these objects are then returned whenever you're trying to create a new object instead. So that you don't actually create a new object, you just reuse the same old object, and it doesn't get garbage collected, and therefore there's no need to create a new object. And another thing that I've just recently introduced is multi-threaded loading of entities. So currently, a bottleneck here is that when you're trying to create, say, 1,000 entities in one frame, this can take a lot of CPU time, meaning that you won't have a good frame rate of 60 frames per second. And in that particular frame especially. So there is now, when you're trying to create that many entities, it will be preloaded on a background thread. And when you request them, the preloaded entities will be given to you rather than creating new entities from scratch. And so yeah, there's extensive use of pooling when needed in critical sections. But for things like to-value data structures like point, there isn't much in terms of gain, I think.
Cool. Any more questions from the floor? Oh, one more at the back. If you could grab the mic.
Trying to work out whether this is a dumb question or not. Where you've got components in your entity component thing, if they're sharing data like position or something like that, like how do you control what order they get applied?
There is a thing, there's an annotation called required. So if you're, suppose we have two components, view and position. Position needs to be added first because the view requires position data. And so the view component class would have a class level annotation saying required, and that required will have the position components class. So whenever view and position are added, FXGL will make sure the position is added first because it's the thing that is required by something else. In fact, I might be able to find that. Right, that's one other thing I should mention. You can't actually decompile this. It's written in Java and Kotlin and JavaScript. So there are actually 3 languages in which FXGL is written. Most of the high-level abstractions are written in Java because Java interfaces are nice. And there are certain compatibility problems that I don't quite like with Kotlin. And Kotlin is a pragmatic language, so all the concrete implementation details are really nice to use Kotlin for. And a bit of JavaScript thrown there is for scripting. So if you want to have a level in which you might have a button, you press that button and there's some code executed. That code is typically going to be written in JavaScript because you don't want to recompile your game if you want to change some level data because it's external data, not part of the game.
Cool. So if there's no more questions.
There are 2 physics engines in FXGL. One is Box2D, which is the real physics simulations. And the other engine is, yes, I read it myself, which does the non-physics it doesn't do physics simulations. It checks things like collision detection. because we don't want to use the heavy simulations when we just can get away with checking collision between two boxes.
Any more? Cool. So in that case, just one more round of applause for tonight's speakers. So, a couple of little parish announcements before we head off. First of all is Brandwatch, tonight's sponsor, is recruiting at the moment, and that's both for JavaScript, Java, and we have graduate positions and summer internships just about to open up as well. So if you're a student joining us tonight, there's positions available as well. If you have any questions about that, you'd like to chat to any of the Brandwatch staff, I'm here, as are a few other Brandwatch members tonight, so do come and grab us afterwards. We are going to decamp from here to the William IV pub. So head out the front doors of the building, down the road about 100 yards, it's on the right-hand side. And I think that's it for tonight. So thank you all very much for coming, and we hope to see you at a future event.